This week you've been learning about the Pythagorean theorem. Today we're going to learn how does the distance formula relate to it. The distance formula is when you find the distance between 2 points. The formula says d equals the square root of x2 minus x1 squared plus the difference of y2 minus y1 squared. All right, well, let's think about that. If we were doing the x's, that's the difference going across. That's the a squared part of the Pythagorean theorem. If we were doing the difference in the y's, that's the y squared part, or the going up part, which is the b squared. So essentially, this is like the a squared, and this is like the b squared. So they're very similar. You can use either formula, actually. Okay, so again, the distance formula between 2 points is when you take the difference of the x numbers and add that to the square of the difference of the y numbers. So let's look at a couple. Okay, so here's an example. I'm going to do it both ways. First, I'm going to use it doing the distance formula. So I have P is at 2, 3, and Q is at 1, 1. So if I take a difference of the x's and I do 2 take away 1, that's the square root of 2 take away 1 squared plus, now we'll put in the y's. That would be 3 take away 1 squared. Think about that. 2 minus 1 is 1 squared plus 3 minus 2, that's 2 squared. So that's 1 plus 4. That's the square root of 5. So this would be the square root of 5. So let's look at it this way. If I do it as the Pythagorean theorem, just count. That's 1. See the same 1 we got there. That's 2, the same 2 we got there. And we know we did a squared, 1 squared, plus 2 squared. The same thing we got here. Or 1 squared plus 2 squared equals c squared. That equaled 5. And when we solved for c, we got the square root of 5, which is the same answer. Let's try a couple together. I find I use the distance formula when I'm on a grid. So I'm just going to count. I'm going to make my triangle and count. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. So this would be 7 squared plus 6 squared equals c squared. When I do that on my calculator, 7 squared is 49 plus 6 squared is 36. That's 49 plus 36. That equals c squared equals 85. So c would equal the square root of 85. And if I take my calculator and do the square root of 85, second square root, 85, second square root 85, I get 9.2. Again, let's try it again. I prefer using the Pythagorean theorem here because this really is the distance. It's 1, down 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. Listen, it doesn't really matter about the positives and negatives because distance isn't measured in negatives. It's always measured in positives. So that would be 1 squared plus 9 squared equals c squared. That's 1. That's 81. That's 82. So we know c squared is 82. So c equals the square root of 82. So again, on my calculator, I am doing second square root 82. And I get 9.1. What if I'm given it as 2 points? Well, this is where I might either draw on a grid and do a squared plus b squared equals c squared, or do the distance formula. So I know I'm putting in my x's first. -2 minus 7, -7 squared, plus 3 minus -7 squared. Minus a minus is a plus. That becomes 5 squared. That becomes 4 squared. Oh, I'm sorry, that becomes 10 squared. Okay. And so then I know that D equals 125, the square root of 125, or D equals second square root, 125. And I get 11.2, rounds up. Okay, last one. D equals. Now, you can do this in your head if you want, or write it down. 2 minus 1. I'm going to write it down. If I was doing it in my head, from 2 to negative 1 is 3 squared, plus negative 9 minus 4. That is going to be 9 and is negative 13, or negative 13 squared. I'm just really worrying about the positive. Make sure we don't do that. So that's the square root of 9 plus 13 squared is 169. So now we know D is the square root of, on my calculator, 169 plus 9 is 178. And if I take the square root of 178, I get 13.34, so that rounds to 13.3. Okay, so you choose. They're the exact same thing, Pythagorean theorem and the distance formula.